Good evening, everyone. Thank you so much for joining our third session on TiL-AI Masterclass series by Dr. Ramesh Chandra Srivastava under the Teacher in the Loop AI initiative. One important update about our next masterclass series, as I shared in the group, it will be on 31st evening at 7 o'clock. Without further delay, I would like to hand over the session to Dr. Ramesh Chandra, sir. Sir, over to you.
Uh, Thank you, Khalid, and good evening, all of you. Now, today I will take the challenging topics of the coordinate geometry, introduction to trigonometry, and the last one is the some applications of the trigonometry. So, uh, I will share the some challenging topics of the coordinate geometry. I am audible or not?
Yes, sir, you're audible.
Yes,
Your
yes, yes,
video is
okay.
not visible, but you're audible.
But okay, no problem. So, the thing is that the some challenging topics of the coordinate geometry is the derivation of the distance and section formulas. And the second one is the concept of external division of a line segment, difference between the geometry and the coordinate geometry, helping students visualize the Cartesian plane. And the real world problem applications. The last one is that the confusion in application of the section formula. Now come on the introduction to the trigonometry. The challenging topics are difference between infinity and undefined. It's a very good topic. And the next one is the finding other t ratios when one t ratio is given. The difference between the geometry and the trigonometry and understanding trigonometric ratios and functions. The next one is the importance of angle in trigonometric ratios, confusion in treating a numerator, denominator of a ratio as a perpendicular base and hypotenuse. Application of the trigonometric identities correctly. And the last one is that the proving or finding the value of expressions when variables are in trigonometrical ratios form. And the last one is that is the some applications of the trigonometry. The drawing and labeling right-angled triangles from the word problems to objects or to observation-based trigonometrical problems, problems involving angles from the two different points, identifying angles of elevation and depression. Height versus distance confusion. That is the mixing of vertical height and horizontal distance. The choosing the correct trigonometric ratios. And the last one is of this mixed angle of elevation and depression problems. These are the some challenging topics of the 7, 8, and 9 units. That is the from the coordinate geometry, introduction to trigonometry, and some applications of the trigonometry. So I will take the session on these challenging topics. So now I'm going to share my PPT. Please wait the few minutes. Now, first of all, I will take uh, the unit 7, the coordinate geometry. And I think that As screen is visible or not?
Visible, sir, visible.
Visible. Okay, okay. Now come on the topics. That is the when we start the coordinate geometry, why we need the coordinate geometry to understand the some our real life problems. Like that, finding a shortcut. That is, imagine a town laid out on a perfect grid like a map. Your home is at a point A. Suppose the coordinate of the point A is 3, 1, and your friend's house is at a point B, 6, 5. And we can reach from point A to the point B in the two ways. First of all, the walking by road, and the second one is the taking a shortcut. The walking by road, walk 3 units east, that is the change in x-axis, and 4 units north, changing in a y-axis. The total distance traveled by someone is from A to B is 3 plus 4, that is the 7 units. Now, let's take taking a shortcut way. If you could walk straight through the field, diagonal path, this is the shortest distance. The straight path is the hypotenuse of a right angle triangle formed by the roads. That is, the distance will be the square root of the change in the x square plus change in the y square. That is the root of 6 minus 3 whole square plus 5 minus whole square. In this way, we get the 5 units. This is the shortcut distance from point A to the point B. So we can we can derive a distance formula through this example, that the distance between the 2 points having the coordinates x1, y1 and x2, y2 is given in the textbook, that is the root of x2 minus x1 whole square plus y2 minus y1 whole square, or we can write it as both are the similar formula, the root of x1 minus x2 whole square plus y1 minus y2 whole square. Now, the section formula is given in our textbook, NCERT textbook, only for the internal proportion. But here we will see some external section formula also. First of all, it is a very obvious that if the P point having the coordinate, if we want to find the coordinate of the point P, when coordinate of the point A and B are given, then Pxy is equal to mx2 plus nx1 by m plus 1, my2 plus ny1 divided by m plus n. So this is a very obvious formula. It is given in your textbook. Now here, the MNR, the P point divides the AB line segment in the ratio m is to n. And this formula is derived in a very easy way. The midpoint formula is also when the m ratio n is equal to 1 ratio 1, then we can get the formula of midpoint through that the internal section formula. Now, this is some important, the external division formula. It is not given in our textbook, but it is also the same as per the internal section formula. If the point Pxy divides the line segment AB externally, this is the students face some confusion. What is the external division? Now come on this figure. When the line segment AB is externally divided by the point P in the ratio of m is to n, that is AP ratio BP. This is a very important. That is the not AB ratio BP. That is the AP ratio BP is m is to n. Then we can find the coordinate of the point P, which divides the line segment AB externally. That is the formula is given with this figure. That is the m x2 minus n x1 mx2 minus nx1 divided by m minus n, my2 minus ny1 divided by m minus n. But here it is a very important how we use the properties of the similarity of the triangles. When we, in the last session, the similarity of the triangles is very important in coordinate geometry, in the trigonometry, in so many fields. Similarity and congruency of a triangles, these two properties of a triangles are very important. Here, in derivation of the internal section formula as well as external section formula, we used the similarity properties of the similarity of the triangles. In the internal, that is the if P divides the AB internally, then we get the two triangles and both are the similar. And with the properties of the proportionality theorem, we get the coordinate of the point P. And in the external section formula, also we used the two triangles, similar triangles, and that is the ADP and BEP. Both are the similar triangles, and with the properties of the similar triangles, we derived the section formula, external section formula. So property of the similarity of the triangles is a very important. Now, applications of the distance formula. What is the applications of the distance formula? That is, d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. So let's take the some very application of this distance formula in navigation and GPS. How we can use this distance formula in navigation and GPS? Calculating the shortest distance and route between the two locations. It's the core of how maps convert spherical coordinates. It is a very important, a new keyword is used, that is the spherical coordinates. I will discuss this spherical coordinates in this session in the introduction to the trigonometry. That is how we can convert the Cartesian into the spherical coordinate. And here only we can use this spherical coordinate to find the location of some object. And the second application is aeronautics. Determining the required distance between the two aircrafts for air traffic control to prevent collisions. So distance formula is useful in the engineering, in aerospace phenomenon, like that in the aeronautics. And cartography and surveying, used by surveyors and map makers to accurately measure properly boundaries, plots corresponding to real world locations. When a surveyor draw a map, then the distance formula is very applicable, because through that distance formula, we can magnify the distance in the real situation. And it is also applicable in the computer graphics, used in games and simulation to determine if objects are close enough to interact or collide. And also useful in the astronomy, that is calculating the distance between the celestial bodies. And this is the some applications of the distance formula. And we use the day-to-day life this distance formula, not only in our day-to-day problem solving situations, but also it is a very useful in the research purpose, like in the biological sciences, in the some engineering. So these are the not standard of the 10th, So that is why I take the only examples which are applicable in our day-to-day life. Now, applications of the section formula. This is also important in our day-to-day life. First is the urban planning and engineering. This is the determining the optimal locations for a common resource transformers, bus stop, hospitals that needs to be located along a path and should proportionally serve to endpoints. Like if we want to establish some bus stop between the some points of the city, then where we can locate the bus stop or hospital or transformers or any uh, resources. So we can use the section formula that what will be the proportion, distance proportion between the one point uh, to that bus stop or hospital and the distance from the second point to that bus stop or hospitals or transformers. So the section formula is very applicable in urban planning and engineering. Now, architecture and construction. Calculating the precise position for a support beam or a pillar along a structure is meant to distribute load in a specific ratio. In metro station, in metro route, so we can see the location of the pillars, and that is the how to find the coordinate of that point P, which divides the whole track, yeah, section of a track into the some ratio. So we can locate the position of the pillar as well as the beam in the some civil structures like a metro or bridge or whatsoever. Now come on the next unit, that is the introduction to trigonometry. It is a very important, and in the last session so many queries were there at that time. That is the what is the unit circle, and so many questions about that the trigonometry. So I will reply all the queries uh, of, regarding the introduction to the trigonometry or regarding the trigonometry. Now, what is the how we need the trigonometry? First of all, we will go through that the introduction to trigonometry. Geometry switches over to trigonometry by quantifying. The quantifying is a very important term. The geometry switches over to trigonometry by quantifying the relationship between the angles and the side lengths of a triangle, particularly the right angle triangle through the use of ratios, and that is after that we call it as a trigonometric functions. Now, how we can introduce the trigonometry in our real life, or we can take what is the need of the trigonometry? That is, the trigonometry is a computational subset of geometry, while geometry deals with the qualitative properties of the shapes. What a triangle is, its angles, some of the angles is 180-degree. So these are the, we can say that is the qualitative properties of a shapes. But here in trigonometry provides mathematical tools to measure those properties precisely. The foundation of the trigonometry. The geometric principle of similar triangles bridges the two fields. This is a very important line. That is, we go from geometry to trigonometry with the properties of the similar triangles. The similarity of triangles is very important in the foundation of the trigonometry. Without the using of the similarity property, we cannot develop the trigonometry. So this is the main property of the trigonometry, how it correlates with the geometry. That is, the geometry principle is a we can use the similarity properties of a triangle to develop the trigonometry, and that bridges the two fields. The foundation of the trigonometry. in geometry, we know that any two right triangles that shares an acute angle theta are similar. Now, why we take the two right angles triangle? This is the very important. In geometry, we know that any two right angle triangles, if we take the two right angle triangle, the one angle is the 90-degree, other two angles are the acute angles. And we take the one of the acute angles, suppose it is a theta. Then if the theta are similar in both the triangles and 90-degree, the right angle is a similar, then third angle will be also the equal. So through the AAA, both right angle triangles are similar. So we can use the similarity properties in both the right angle triangle. So that is why we take the two right angle triangles for the development of the trigonometry. Now, because they are similar, the ratio of their corresponding sides is constant, are the same, that is the constant, regardless of the triangle's actual size. It is a very important line. If we take the two triangles, two right angle triangles, and we take the some angle theta in both the right angle triangles are same, then if we uh, have the different size of the arms of the right angle triangle, then always we will get, if both are similar, we will always get through the properties of the triangles as some constant. That is, if we have the some right angle triangle ABC and DEF, then the theta is common. Suppose in ABC, B and DEF, E are equal, then both will be similar. And we can apply the properties of the similarity of the triangle, and always we get the same ratio of the sides of the triangles. And that is the proportion is known as the sum. In this, we can see one thing. Yes, like in the trigonometry, formalizes this constant ratio by naming it as a trigonometrical ratio. Functions of the angle theta. Here, the function is a very typical word. So only come this ratio of the sides is a constant, and this ratio is known as the functions of the angle theta. That is, we can take the ratio in some six way. That is, when the sides of the right triangles are defined relations to an acute angle theta, and these relationships are given as the trigonometrical ratios. Like that, if we take the ratio of the altitude divided by hypotenuse, this ratio is said to be the sine. This is the angle of theta. The cos of the angle of theta, tan of the angle of theta. In this way, the base divided by hypotenuse, the altitude divided by the base. So uh, we can get the six type of the ratios in the form of the sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Now, now come on this. It's a very good question in the last session. That is, what is the difference between the trigonometrical ratios and the trigonometrical functions? And the question was about that unit circle. So now today, I will give you the complete reply of this your last query. That is the what is the unit circle? What is the difference between the trigonometrical ratios and trigonometrical functions? Now, in the last slide, you saw that in right angle triangle, one angle is the 90-degree, and the rest of the two angles are the acute angles. And suppose the one acute angle is a theta. So we can take the ratio, different ratio of the sides in six way. And we named that ratio of the altitude. The opposite side of the angle theta is altitude. The opposite of the 90 degrees is hypotenuse, and the third side, adjacent side, is a base. So sine theta is altitude by hypotenuse, cos theta base by hypotenuse, and tan theta is altitude. And the reciprocal of these cosec theta, sec theta, and cot theta, these are the normal things. But here it was a very important that we take the theta as an acute angle only. We can describe 6 trigonometrical ratios only for the theta when the theta is an acute angle. Now come on this figure. On the screen you can see it very easily that when we draw a unit circle, that is if we take the unit radius circle, and this circle is having the radius 1 unit, 1 centimeter, 1 inch, whatsoever, then what will be the position of the angle theta? Here in the first quadrant, the theta is the acute angle. P is any point on the circle, and when we draw a perpendicular from P to the base on the x-axis, the feet of the perpendicular is M, and the triangle OEMP is a right angle triangle, theta is an acute angle. And here the hypotenuse of the 1 unit. Then what will be the cos theta? That is the OP, OM divided by OP. If the Cartesian coordinate of the point P is xy, then x, what will be the x? That is OM. Then x divided by OP, that is x by 1 is equal to cos theta, that is x is equal to cos theta. In the last slide, we discussed the spherical coordinate. Here, when we think about the side and the angle both simultaneously, then here we can change the Cartesian coordinate of P. The abscissa x is equal to OM by OP. That is in the trigonometrical ratio, we can write it as cos theta. And the ordinate y, that is the PM divided by OP, that is the sine theta. That is y, we can write it y is equal to sine theta. So we get the two form of the coordinates of the point P, xy in the Cartesian form and in the some trigonometrical ratios form, that is the cos theta, sine theta. So this is the spherical coordinate where the angle is included in this concept of the unit circle in the first quadrant. Now, trigonometry is the generalized beyond the right triangle using this unit circle centered at the origin. Here, the geometrical concept of coordinate xy are directly replaced by trigonometrical functions. Now here, the trigonometric functions concept with the unit circle. Now if we come in the second quadrant, here the theta is not acute angle. When we rotate in anti-clockwise, that is the angle XOP, that is the some obtuse angle, and that is not acute angle. Then how we can get that sine theta, cos theta, tan theta? Because it is not restricted for the acute angle. So here also, what will be the x? That is the cos theta, and y is equal to sine theta. But if the theta lies between the 90 to 180, that is in the second quadrant, then x will be the minus cos theta and y will be the sine theta. So the coordinate of this, the point of x in the second quadrant will be minus cos theta and sine theta. Similarly, when theta goes in the third quadrant as well as in the fourth quadrant, so theta is not restricted for the acute angle. So that is why here, if sine theta, cos theta, tan theta is defined for any angle, not only for the acute angle, then at that time, these trigonometrical ratios is said to be the trigonometrical functions, because we have the concept of the function where the domain is the set of the some real angles, and the codomain is the values of these trigonometrical functions in the codomain. So here at the 10th standard, we can differentiate between the trigonometrical ratios and the trigonometrical functions. Trigonometrical ratios are only defined for the acute angle, and trigonometrical functions are defined for any type, any angle that lies between the 0 to 360 degree. So here we will discuss about that trigonometrical ratios and trigonometrical functions. So let's wait. There is some interruption in our Zoom. So now trigonometrical ratios of 0 degree and 90 degree. And trigonometrical ratios of the 0 degree, when we make some triangle of 0 degree, we cannot make the exact of the triangle of the 0 degree. That is the acute angle was very close to that the 0 degree. Similarly, in the case of the triangle of 90 degree, that is very close to the 90 degree, then that is the limiting case. And cosec 0 and cot 0 are not defined because what is the sine 0 is 0, then cosec 0 is equal to 1 by 0. That is not defined, and we will discuss these things. That is what is defined and what is undefined, what is infinite. So in the case of here, the cosec 0 is not defined. What is the undefined? So we will take after this discussion, what is the undefined, what is the infinite, and what is the indeterminate. Similarly, in the case of tan 90 degree and sec 90 degree is also not defined because these things are the some category of the undefined. And in our 10th grade mathematics, the trigonometrical identities are given. In algebraical identities, we are very familiar, like that x plus y whole square is equal to x square plus 2xy plus y square. Similarly, x minus y square, x minus y whole cube, like that. So on that, in the algebraical identities, the identities are they are satisfied for infinite number of the variables. Similarly, in our trigonometrical identities, the trigonometrical identities are equalities involving trigonometrical functions that are likewise true for all values within the domain of the variable. It is not only for the acute angle. Theta here is not necessarily for the acute angle, but these identities sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. 1 plus cot square theta is equal to cosec square theta. These trigonometrical identities for any value of the angle theta. Now here, now we will discuss about that the undefined as well as the infinity. You all know that the divisibility by 0 is undefined. And but why it is undefined? because if we divide the 1 by 0, then what will be the quotient? When 1 divided by 0, it is the why it is undefined. Undefined means that is the mathematically wrong. When we divide 1 by 0, that is 0 1 is 0, 0 2 is 0, 0 3 is 0, and you will give uh, can see that the remainder always will be the same, that is the 1 1 1 1, and the quotient will be some infinite number of numbers. So this is not some mathematical, it doesn't follow the mathematical operation principle. That is why it is undefined. But what's about the 0 by 0? What is 0 by 0? Is suppose 0 by 0 is equal to x. It means that when we multiply 0 into x, we get always with 0. So that is, you can put the value of x 1, 2, 3, 4, infinite number of value you can give the value of x, always you will get the 0. So there is a no mm, some a definite value of x, that is why indeterminate. Not a definite number, but is you can get the value of x in uh, um, large number of the natural numbers, or you can get the some large number of the real numbers. That is why it is a indeterminate. And but what is the infinite? Infinite means that is the some not a definite number and not some definite number, but it is some huge number. Suppose if some in most of the student they ask that 1 by 0 is infinite. How they answer it? Because 1 by 0 means that is the, this is the limiting case when we put the 1 by 0 0.01, 1 divided by 0 0.001, 1 divided by 0 0.0001, then we get the 100, 1,000, 10,000. So that is why in the limiting case we get the some infinite numbers. That is why they say, but that is the limiting case, not some absolute case. In absolutely, we cannot divide any number other than 0. So divisibility by 0 is undefined. But the 1 by 0, in the only in the limiting case, we can say it is some positive infinity or negative infinity. But that is the some the different case. That is the limiting case. And now applications of the trigonometry. What is the applications of the trigonometry in our textbook? The only height and distance questions are given. How we can get the height of a building, height of a tower, height of a pole, and the distance of the pole from the observer. So like that questions are, so many questions are given. But here the some applications of the trigonometry, not it is only restricted for the height and distances. We can see here trigonometry is used in daily life to calculate heights, distance, angles, and periodic phenomena. In navigation and surveying, GPS system works on the sine and cosine, spherical trigonometry. That is not in the Cartesian form because latitude and longitude, these are given because the earth is not a plane surface, that is the some curved surface. That is why we take a circular concept of the unit circle, like that in the unit circle, and we change the x into cos theta and y into sin theta, and that coordinate is useful for the uh, in as a spherical trigonometry to find out the location of any objects in GPS system. It accurately calculates the distances and angle from a receiver to multiple satellite. Because in the some curvature, in the some spherical concept, spherical surface, we use the concept of the angle, the distance and the angle. That is why we use the spherical trigonometrical approach here. So in the GPS, the cosine and sine and cosine, this is the very useful, and to determine the user location, on Earth's current surface. Now in surveying, land surveyor use it to measure land boundaries, property lines, and to determine the elevation and inclination of a plot of land for construction. In civil engineering, in so many surveyor, and they use this trigonometrical concept in location of the boundaries, or some the structure of the building, or the structure of the road, or the some any civil work for the elevation of the road as the inclination of a plot of a land for the construction purpose. Now, measuring the heights and distances, this is the so many questions are given in our textbook regarding the height and distances. The trigonometry help us to find the heights of a building, tower, or tree without actually climbing it. So here also the properties of the similarity of the triangle, which is now it in the form of the trigonometry, and we can use the similarity of the triangles, or with the help of the trigonometric, we can find without the climbing of the tower or building, we can measure the height. Now in astronomy, by applying trigonometric principles, astronomers can find the distance of stars and planets from the Earth. So with the telescopic angle of elevation, and we can measure the angle, and through that trigonometrical approach, we can find the distance of the stars and planets from the Earth. So now, sound and music. The wave patterns that if you go through that, the wave function, that is the wave function is in the form of sine theta. That is y is equal to some a sine theta. In 11th class or in 12th class, in the sound as well in the electricity is also it is very useful. So the sine function, cosine function, so these are the some nature of the wave functions. So the wave patterns of sound are represented using trigonometrical functions, and like sine and cosine functions. So, and medical field, because in our bodies, our body in internal part of our bodies are in the brain. That is not some plain surface. Here, in the CT scan as well as in the MRI, we can find the some images of that organs. Those are in the curved form. When we use the some elevation of that organs from that to that from the other organs, we use the trigonometrical functions and finding the CT scan and MRI, and also the cross-sectional images of the human body, because the so many parts they are on a solid form, and some the hollow forms, and the MRI and CT scan uh, both machines are built on the basis of the application of the trigonometrical functions. So these are the some important things which we discussed in the some coordinate geometry, as well as in the our uh, introduction to the trigonometry, as well as some applications of the trigonometry. And the challenging topics in our coordinate geometry, or introduction to trigonometry, or application of the trigonometry, and you can some uh, make some OER related to these topics, especially the some OER can be made in the introduction to the trigonometry, and what is the difference between the trigonometrical ratios and trigonometrical functions, and what is the properties of the periodicity of the trigonometrical functions in trigonometrical introduction to the trigonometrical functions in unit circle is very applicable in the higher classes, because in the some calculus the trigonometrical functions are given, and we can differentiate and integrate the different trigonometrical functions, and it is useful to in the differential equations also. So in the modeling we can apply the concept of the trigonometrical function, and that is applicable for the any value of the theta. So these are the some things which we have discussed, and now please wait, and I think that uh, uh, you can ask the questions uh, about that 3 units. That is the where is the chat box? Chat box. That is the polar coordinates can be used to explain complex number as well. As why not? The in our chat box, Sumita Kumari, that is the in polar coordinates. When we take the some radius of r radius of a circle, then we can write it as x is equal to r cos theta and y is equal to r sin theta. And here, you know that in the complex number system, the complex number system is written as a x plus iy. And we can plot any complex number. That is the all the real numbers are the complex. So you can write it all the real numbers in the form of the complex number, that is x plus I0. But here, in this the 10th grade mathematics, only we want to explain the unit circle. That
Hello.
is when I'm audible or
Very
not.
good evening, sir. Yes, you are audible. I just want to
So
say that unit circle
SSS,
concept
you can
was
ask, but here the in the only listen me to for the few
okay.
seconds, then I will reply all the answers.
Okay, sir.
Can be used to explain complex number as well. That is the through that polar coordinates always we can explain the complex number. That the first answer is this, that because the our polar coordinate and the complex number, there is a very closed relation between the complex number, and we can explain the complex number through that the polar coordinate. That is what is the r. What is the r? R is the radius of a unit of the circle, not a unit circle. And we can change the x and y, x plus iy, in the form of r cos theta plus r I sin theta. That is r into the cos theta plus I sin theta. That is the some another approach, and that is the above the 10th grade mathematics. But here we can explain that is the polar coordinate. When we take the radius r circle, we can write it as x is equal to r cos theta, y is equal to r sin theta only in the real number system. But in the complex number system, because it denotes a plane, that is xy plane, and we can explain the complex number x plus iy in the xy plane. So we can switch over the complex number into the some form of the polar coordinate. And what do you want to ask me, Sumita ji? Sumita Kumari.
Yes, sir. Good evening, sir.
Yes.
I was just
Good
to
evening.
say that unit circle is a basic concept used in complex number as well as trigonometry.
Not in a complex number. Here we use the unit circle only for the purpose of the
T
trigonometrical
ratio.
functions. a unit
Yes.
circle. Here in the 10th grade mathematics, we use the unit circle because our x is equal to cos theta and y is equal to sin theta, because cos theta divided, that is the x divided by 1 is equal to cos theta, and 1 is a 1, that is why x is equal to cos theta sin theta. That is the some trigonometrical function, and it is applicable for any value of the angle theta. That is the trigonometrical function. We can use this concept in the polar coordinate. When we take the as a r radius, then we can change it to into x is equal to r cos theta and y is equal to r sin theta. And the if we plot any complex number at the point P, then we can write as a r cos theta plus r I sin theta. That is something different from that. It is the trigonometrical function concept. Our next question is, always give the same type of the explanation in the class, but nowadays the students get bored. Because if you uh, take the properties of the similarity of the triangles, and with that approach you define the trigonometrical ratios, that is the ratios of the two sides of a right angle triangle, and whatsoever be the size of the altitude and the hypotenuse, if the angle is same, that is theta is same, then you will always get a same ratio. If that is if you uh, theta, suppose your theta is equal to 30 degree, and in right angle triangle, the altitude and hypotenuse, the size is different. And in other right angle triangle, if theta is 30 degree and altitude and hypotenuse is some different, then always you will get the same ratio. That is the trigonometrical ratio, especially for the acute angle.
Good evening, sir. Excuse me.
Good evening.
Sir, my question is that some of the students are confused that sine theta is the ratio of perpendicular and hypotenuse. So they are asking, is it only to memorize or some logic of Aryabhatta or whatsoever? Would you
So
please?
theta is because if you take the some sign, suppose altitude, that is it is a general a convention that opposite of that acute angle you take the altitude, and the hypotenuse is a fixed, that is the opposite of the right angle. And third side is also the, you can say that the base of the right angle triangle. If we take
But
the, suppose ABC is a triangle, and you take the
mm,
angle A, then at that time the altitude, it is general
mm,
convention. And you take that altitude is the BC of the angle A. So these are the general convention, and many students they have the misconcept about that. In triangle ABC, always BC is a base.
no, no, no.
BC is a base. Uh,
I'm
so
asking,
that,
students are asking
uh,
why it is the ratio of perpendicular and hypotenuse. Only the question they are
oh no,
asking.
no, no. You can take, you can name it as a not only sine theta. You can name as a some a different number, a different vocabulary. Not only the sine theta, but if you take the ratio of the altitude, the two sides, any two sides. Suppose here the altitude divided by hypotenuse, base divided by the hypotenuse, altitude divided. You can give the some another name, but when you fix the some name, that is the this side divided by this side is always the sine theta. That is the some general some you can there that if we write it as a in Hindi vocabulary or English vocabulary. So that is why we take the ratio and named as a sine theta. As this is a general convention. You can write it if we in the starting if we write it as a tan theta, then that will be the tan theta. But here it is just the ratio of the two sides, any two sides, and we have the six different ratios of the sides. 2 and 3 and opposite of the 3, the converse
Yes.
of these three ratios. That is why we named this as a sine theta, cos theta, tan theta. And it is a Greek approach. And I can say that through this properties of the similarity of the triangles, we develop the geometry into the trigonometry. Only with the property of the similarity of the triangles. In the geometry, we take only the sides and shape, But in trigonometry, we also involve angle also. That is why the trigonometry is the special branch of the geometry in which we consider about the angle also. So here in the shape, where the angle is involved, that it takes the shape geometry into the trigonometry.
Thank you, sir. Thank you.
Thank you. Welcome. Any question?
Sir, there is one more
Yes, sir.
question on the chat
Hello.
box.
As the
Hello.
chat box,
I have a
chat box,
concept
yes, yes.
by Anshu Grover, ma'am.
Anshu Grabar, yes. 1 minute, please. Screen is not visible. So now the screen is visible
Meanwhile,
or
may I
not?
ask a question, sir?
1 minute.
Hello.
Yes, why not?
So my question
That
is,
is the yes, please.
yeah.
Good
So
evening,
my
sir.
question is, when we use words tangent and secant in geometry, we explain it as a line, segment, or line. But when we use secant and tangent in trigonometry, we say it as a ratio. So how these two same concept are same name has two different concepts. At one place it is considered as a line or line segment, and in another chapter it is considered as a ratio. So how can we connect
That
both of
is
the
the
concepts
tangent.
together?
That is the tangent. That is in geometry. The tangent and secant. These are the geometrical concept with the help of the tangent. We switch over in the trigonometry. Here in the trigonometry, suppose a secant is given of a circle or any curve. Suppose here we only take this about the circle. A secant. What is the secant? Is a that is the intersecting chord. And when the both the points coincide as a point, it is said to be the tangent. Here in the case of the trigonometry, when we take the unit circle position, and if we take the point, suppose tan theta, if the theta is the acute angle or obtuse angle or reflex angle whatsoever, what is the altitude divided by base? What is this? How it is associated with that tangent of a circle? Because the both the points, if the point P is very close to the point, suppose the point M, the feet of the perpendicular very close to the point M. P is very close to it is a very small angle of theta, that is the acute angle. Then what is the ratio? That is the ratio of tan theta, that is the altitude divided P is very close to M. That is the both points are very close to that, that makes a tangent. That is in the geometry, the line of the secant makes a tangent. Here in the unit circle, the P is very close to the M. In that time, it makes, you can say that at the point M, it behaves like a tangent. So when theta is very close to the, you can say not equal to 0, but very close to that, theta is very acute angle and very close to, P is very close to the M point, that is the feet of the perpendicular, that lines that at the point P we can get a tangent at the point M. So in through geometry, when we study in the trigonometry, the angle concept is always involved. But in the geometry only we study the shape of the geometrical figures. We cannot consider the angle, and when we consider the angle concept, then we will go in the trigonometry, where the shape as well as the angle elevation is a very important, and we generate some new words like the trigonometrical ratios or trigonometrical functions. So these are the things which are related to the geometry, but the one parameter is also involved in this geometry, that is the angle. So when we study the size and the angle of any triangle, then we go in the domain of the trigonometry. And when we study only about the sides of properties of the sides of any triangle, then we study in the geometry. So in the trigonometry, the secant and the tangent, so these are the some geometrical names. But in our trigonometry, the sine, cos, tan, sec, cosec, so these are the sub ratios of the sides of a triangle with the in the view of the angle also. So this thing is different from that secant and tangent from the geometry. Now in our chat box,
Good evening, sir.
yes, ma'am.
Sir, my name is Anshu Grover. I am having
Uh,
I have a conceptual query regarding coordinate geometry, which you told
yes,
right now. With the help of similar triangle, you told we can find out the external division formula.
yes.
Now,
With the
so I
application of
my
the similarity of the triangles, yes.
yes, sir. So my question is, instead of deriving the formula to external division, can we solve such questions using the internal division formula by applying the proper sign convention, like taking one ratio as negative? Is this approach conceptually correct, or will it lead to?
Ratio cannot be negative, ma'am. Ratio
So,
is some the ratio is always the some positive the proportion of the two some positive integers. A
yes,
ratio
that,
cannot be, that is m and n cannot be in the some positive, m is positive and is negative or both are negative. So only the ratio is always that m ratio and the external section formula, suppose 3 is to 2 or whatsoever, the ratio cannot be negative. Ratio is the sum property of the positive integers. Ratio is you cannot take the ratio as a negative,
no,
because
no,
if you get the negative ratio, as I want to tell you, suppose m is to n is equal to 3 is to minus 1, suppose, so minus sign always denotes the external division, that is it is a sum out of that ab, if you have the some definite point a and b, that is the out of that. So only for the remembering point of view, you can derive, you can remember the formula mx2 minus nx1 by m minus 1, where you take the n is equal to minus n. So that is not a right way. Always when you take the similar triangles and the size of the uh, sides of the similar triangles are always positive. There is no concept of the negative. And the ratio is also positive, always positive. But if you get the answer in the negative proportion, it shows that only it is a signal of that the point is out of the point AB. That is the external section formula is involved there. But
yes,
always you get the M ratio, and that is the absolute value of the M into M of N, not the either neither m may be negative nor n may be negative. So the similarity of the triangles always is useful to find the external division section formula.
सर
actually, I
नमस्कार।
have
Namaskar.
सर सबसे पहले तो हम सेमका का और आपका धन्यवाद करना चाहते हैं कि हमें इतनी नई चीजें भी सीखने को मिल रही हैं जिनके बारे में हमारी नॉलेज अपडेट नहीं थी। और सर एक रिक्वेस्ट मैं करना चाहती हूँ हम सबकी तरफ से कि सर जैसे आप इसके अभी हमें जो करंट में जो यूज चल रहे हैं कि जैसे आज आपने बताया सीटी स्कैन में या फिर और है, जैसे पहले आपने ब्रिज में भी बताया था सर। तो सर हमारे हमसे बच्चे जब पूछते हैं कि भाई बच्चे इसका यूज कहाँ होगा, तो हम सर केवल उनको ये कह देते हैं कि ब्रिज में होगा, इंजीनियरिंग में होगा, ये होगा, पर हम
नहीं
उनको
तो
सर
वो,
संतुष्ट नहीं कर पाते हैं।
हाँ,
सर
तो
मैं
मैं
ये,
बता रहा हूँ आपको।
हाँ जी,
ठीक है, उसको हमें बताना पड़ेगा कि कैसे यूज हो रहा है, कैसे
अच्छा,
यूज हो रहा है। केवल ये बताने से नहीं काम चलेगा कि हम नेविगेशन या जीपीएस में यूज कर रहे हैं। तो
हाँ जी
उसको
सर,
हमें ये विजुलाइज करना होगा कि हम उसको यूज कैसे कर रहे हैं। जैसे मान लीजिए कि मैंने अभी आपसे बातचीत में ये बात कही कि
हाँ जी सर,
हम जो है सेक्शन फार्मूला यूज कर रहे हैं कहाँ पर, किसी पिलर के लोकेशन के लिए। अब
हाँ जी
उसको
सर,
आप हाँ, आप जैसे मान ले एक ये यूज है उसका एप्लीकेशन कि पिलर्स के, तो आपने जैसे कि कोई मेट्रो ब्रिज है, मेट्रो ट्रैक है, और उसमें किसी पिलर को हमें एक पॉइंट से दूसरे पॉइंट पर 5 मीटर पे रखना और दूसरे से 3 मीटर पे रखना है, सपोज। तो
हाँ जी
हम
सर।
उस सेक्शन फार्मूले से हम 5 और 3 की जो डिस्टेंस है, जो रेशियो है, उससे हम ये पोजीशन उसकी पिलर की फिक्स कर लेंगे कि ये पिलर हमें कहाँ फिक्स करना है।
हाँ जी सर।
अगर यही रेशियो हम उसको 4:3 पे करना है, तो पिलर की पोजीशन चेंज हो जाएगी रेशियो चेंज होने से। तो
हाँ जी सर।
हमें कहाँ पर स्टेबिलिटी मिलेगी, वो उसकी पोजीशन को। अब जैसे मान लीजिए कोई शहर है, उसमें हॉस्पिटल हमको ऐसी जगह बनाना है जहाँ
हाँ
पर
जी सर।
कि आदमी को अप्रोचेबल हो। तो वहाँ पर क्या करना है कि हम शहर की मान लीजिए कि नॉर्थ टू
लोकेशन।
साउथ, नॉर्थ टू साउथ मान लीजिए 10 किलोमीटर में सिटी है। और तो
हाँ
हमें
जी सर।
हॉस्पिटल का रखना है जहाँ पर कि क्राउडेड है इलाका, क्राउडेड है जहाँ पर पॉपुलेशन ज़्यादा है। तो हमने उसकी मान लीजिए कि 10 किलोमीटर में 2 किलोमीटर पर क्राउड ज़्यादा है और उधर 8 किलोमीटर पर क्राउड कम। तो हमें 2 किलोमीटर डिस्टेंस पर करने के लिए, उसकी लोकेशन के लिए हमें सेक्शन फार्मूला यूज एप्लीकेबल हो जाएगा, 2:8 का। तो ये सारी चीज़ें हमें बतानी पड़ेगी जब टीचर उनको टीच करेगा क्लास में। तो खाली नाम
हाँ
नहीं बताएगा कि हमें
हाँ
ये
जी
ये
सर।
यूज होता है, ऐसा नहीं। उसको बताएगा। ये तो मैंने हेडिंग्स आपको इसलिए बताई कि इसमें आपको एक्सप्लोर करना होगा कि हम
हाँ जी।
कैसे सेक्शन डिस्टेंस फार्मूला कैसे यूज कर रहे हैं। अब जैसे मैंने बताया कि ए से बी तक जाने के लिए कई रास्ते हैं। एक लॉन्ग
हम्म।
लॉन्ग रूट है, एक शॉर्टेस्ट रूट है। तो उसको
हम्म।
ऐसी चीजें आपको विजुअलाइज करनी होगी, रियल लाइफ
सर।
में, डे टू डे लाइफ में बताना होगा। खाली
सर
बात
मैं
करने
ये
जैसे मैं, जी बताएं।
हाँ जी, हाँ जी। सर मैं यही पूछना चाह रही थी कि जैसे हम अपने नए नए यूजेस को एक्सप्लोर करना चाहें तो सर क्या हमारे पास ऐसी कोई पोर्टल है
हाँ
या फिर सर एक।
है।
हाँ
नहीं नहीं,
ये
देखिए
यही पूछना
ऐसा
चाह
है,
रही
मैं बता रहा हूँ। आप ऐसा पोर्टल के लिए आप ऐसा कीजिए कि आजकल तो आपके लिए सबसे ज़्यादा ज़्यादा आपके पास हेल्पफुल है कि एक कैबरी है, सॉफ्टवेयर है। एक
कैप्री।
ऑटोग्राफ सॉफ्टवेयर है, कैबरी, CABRI, कैबरी है।
CABRI कैप्री।
ऑटो, हाँ, ऑटोग्राफ है। डायनेमिक
ओके सर।
ज्योमेट्री है। ये आईसीटी
ओके
है।
सर।
और आपके एआई टूल की मैं बात ही नहीं कर रहा हूँ। एआई टूल की बात तो तब करना ठीक होगा जब हम एआई को जाने। आप
हाँ जी
चैट
सर।
जीपीटी से या जेमिनाई से बात करके और कुछ चीजें आप समझ सकते हैं।
हाँ जी
उसकी
सर।
इंजीनियरिंग नहीं जाननी है, उसका सपोर्ट आप ले सकते हैं। लेकिन
हाँ जी सर।
खासकर इन चीजों को दिखाने के लिए, विजुलाइज करने के लिए मैम, आपको
हाँ
ये
जी सर।
सारे सॉफ्टवेयर का सपोर्ट लीजिए, दिखाइए। आपको पिलर की पोजीशन दिखानी है, हॉस्पिटल की दिखानी है, एमआरआई, यहाँ इवन के सीटी स्कैन एमआरआई में कैसे ये यूज होता है, टेक्नोमेट्रिकल
हम्म।
फंक्शंस, ये भी आपको विजुलाइज करके उसमें आपको सॉफ्टवेयर में दिखाना पड़ेगा स्क्रीन पर कि कैसे
सर मैं
ब्रेन का।
हाँ
जी।
जी सर
तो
मैं
ये आप,
यही रिक्वेस्ट कर रही थी कि सर एक हमारा ऐसा सेशन भी हो जाए कि इसमें हमारे केवल जो मैथमेटिकल यूज हो रहे हैं जैसे हम किस
हाँ ठीक
सॉफ्टवेयर
है।
पर कर सकते
आई
हैं।
विल
और
आई
क्योंकि
विल
सर
ट्राई टू,
हाँ।
ठीक है,
हाँ जी सर
आई विल
इसकी सर
ट्राई टू
हमें
गेट
हाँ
सम।
हमें सर इस पे आपके प्रशिक्षण की जरूरत है सर।
नहीं ठीक है,
तो सर।
नहीं हमें
हाँ जी
प्रशिक्षण
सर।
की जरूरत तो है। मैं आपके
हाँ।
एक लास्ट में या कोई भी सेशन में मैं एक थोड़े हाफ एन आवर के लिए इसको ले लूंगा। और
थैंक
कैसे
यू सर।
हाउ
थैंक
टू
यू।
यूटिलाइज द आईसीटी एज द सम सॉफ्टवेयर। So it's very important for the teaching practitioner how to teach
थैंक यू
these
सर। थैंक
things through the some software ICT application.
यू।
So
थैंक यू
okay,
सर।
any question?
हेलो सर।
Yes,
सर मैं नीता लखमानी। सर
जी
अभी आपने
बोलिए।
किस सॉफ्टवेयर की बात करी सर? आईसी, कैन यू रिपीट?
ICT, that is information and communication technology में कैबरी CABRI कैबरी, कैबरी,
ओके सर।
this is the
तो सर ये
some part
गूगल
of
से
the,
मतलब
हाँ गूगल से,
प्ले
ऐसे
स्टोर से
आसान यू
डाउनलोड
कैन
होगा
गेट।
ऐप है कि सर?
ऐप है, ऐप। नहीं नहीं, ये ऐप है और ये एआई बेस्ड है। वैसे तो काम ये एआई बेस्ड है, लेकिन आपको ऐप मिलेगा कैबरी। आप गूगल पर टाइप कीजिए तो मिल जाएगा। कुछ पार्ट इसका फ्री है, कुछ पेड है, तो आपको फ्री वाले से काम चल जाएगा। और दूसरा है ऑटोग्राफ, वो ये पेड है, ये आपको नहीं मिलेगा, ये फ्री नहीं मिलेगा। डायनेमिक ज्योमेट्री फ्री मिल जाएगी, कुछ पार्ट उसका फ्री है। डायनेमिक ज्योमेट्री माने जैसे कि आपको जो भी फिगर्स होंगे वो डायनेमिक फॉर्म में होंगे, करते हुए दिखाए। मतलब वो एलिवेटेड आपको फिगर्स मिलेंगी और वर्किंग मिलेंगी, लाइव मिलेंगी उसमें, डायनेमिक ज्योमेट्री। तो कोई सेशन में मैं इन चीजों को देखूंगा, करूंगा। एनी मोर क्वेश्चंस?
Thank you, sir.
Always please the introduction to the trigonometry is a very important. How we can switch over from the geometry to trigonometry? Only the angle concept is involved in the trigonometry, but the size of the triangles, only the size and shape are only related to the geometry. And when we include this angle concept, then we will switch over in the trigonometry, because we consider the angle as well as the side of a triangle. So this is a very important and it is a identified challenging topic. That is how we can switch over the geometry to the trigonometry. So these are the things, some important things related to the coordinate geometry and application of the trigonometry as well as the introduction to the trigonometry.
Do we have any other queries?
Yes, sir. Sir,
Yeah.
I have one question. You just said that the ratios cannot be negative, and whereas we use values of sine, cos, and tan in negative also, and they are also
Yes, that
ratios.
is
So how can we
that
justify
is
this?
a good question. It's a good question because when we take the acute angle as the trigonometrical ratio, we always get some positive number. But in the trigonometrical function, when we goes through that 0 degree to 360 degree, then we can get as the trigonometrical functions of that in the negative form. That is in the function form. So this is the main difference. When we get the positive ratios, we always talk about that the trigonometrical ratios for the acute angle. And when we get the some negative as a ratio, not a ratio, but a trigonometrical, that is the value of the function in the codomain is the maybe negative. That the sine, cosine, tangent, or whatsoever the trigonometrical functions that works as a function concept. There must be some domain and some element of the output of that theta in the form of sine theta, cos theta, tan theta, whatsoever the function. So we always get some positive or negative result in the codomain. So that works as a function, not a ratio. But in the for the acute angle, we always get the sum. In acute angle, that is the when angle is zero between the 0 and 90 degree, we always get the positive.
Sir, good evening, sir.
Good evening.
Sir, can we say that the moment we said the division is external, then we say that ratio is negative. Ratio is negative, that is a signal that it is external division. So the moment in this case, trigonometry, if ratio is negative, this clearly shows that we go beyond 90 degree. We can relate the
Yes,
two
of
facts.
course, of course, of course. But
Hmm.
that is something different. In the section formula, always
Hmm.
be in the section either internal or external whatsoever. In the external, if we have the some proportion in the negative form, that is suppose 2 is to 3 is to minus 2 or 2 is to minus 1 whatsoever. So that only that is the not a some value of the m and n. Suppose if m is to n is equal
Yes,
to
yes,
2 is
yes,
to
yes,
minus 1,
sir.
that is
Got
not
it, got it.
m is 2 and n is a 1. That is the
Got
sign of
it.
that is the some point intersect the coordinate of the AB externally only.
Yes, sir, they are different. I got it. There it is the value. Got it, sir. Thank you so much, sir.
And one more thing, sir, like ma'am told that when theta is greater than 90, it would be negative. But when theta is greater than 180 and less than 270, then we have positive ratio for tangent.
As the P moves from the first quadrant to second, third, and fourth, in the third quadrant, more than 80 and less than 270, then what will be the angle of theta? That is the angle will be the more than 180 degree. But you cannot make a triangle with suppose 190 degrees, suppose, or 210 degree, whatsoever. But you make some right angle triangle with that moving line. And at that time, what will be the sign of the x and y? According to that, we can find the value of the trigonometrical function sine theta, cos theta, tan theta. In the third quadrant, x is negative and y is both are negative in third quadrant. But when you will make some angle like that right angle triangle, that is if theta is 180 plus theta, then always you can get a triangle of with the 270 degree to that moving line. If you have a pen and paper, then you can draw a right angle triangle in the third quadrant also, where the angle is more than 180 degree. That angle lies between the 270 and that the moving line, that is the OP. And that will make a right angle triangle. In that time, the x and y both will be the negative. Accordingly, you can get the spherical coordinate of that point P in the form of cos theta and sin theta. Any more questions? The trigonometry is a very interesting because our trigonometry is started from the class 9th and here in the 10th class, the trigonometrical identities are the very interesting. I am audible or not, ma'am?
Yes, sir, you're audible.
Yes, sin square theta plus cos square theta is equal to 1. It is not applicable only for the acute angle. It holds for the every angle of theta. That here sin square theta, cos square theta both acts as a trigonometrical ratios as well as the trigonometrical function. Because theta may be the more than 90 degree. Any more questions?
So how can we say that if the theta is more than 90 degree, it will become function, or if it is less than 90 degree, it will remain ratio? What is the criteria to decide it, sir?
That is the criteria mentioned in the development of the trigonometry. When we take, why we take the right angle? First of all, the question is this: why we take the right angle? Right angle triangle, why we take? Because it is a possible the ratio of the two sides in only in the case of right angle when the theta is one angle is the 90 degree and both angles remaining, both the angles are the acute angle. And if we fix the some one acute angle, then third angle will be also equal. So both are similar.
Meow,
Both are
meow,
similar.
meow, meow.
Please mute the mic, please. And here, when the two right angle triangles are similar, at that time we can apply the similarity of the two triangles. And with the property of the similarity of the two triangles, we get the ratios of the any two sides in the sixth way. So that is why it is only possible for when we take the theta as an acute angle. But in the trigonometrical functions, it is not the ratio. That is the sum you can, that is the someone was asking about that the ratio is also negative. That is the sine theta, cos theta. That is not a ratio. That is the value of the function. The value of the function may be positive and that is the range is fixed. That is the some restriction when you teach the function, trigonometrical functions and inverse trigonometrical function, especially in the case of inverse trigonometrical function, there is some more restriction of the domain of that in inverse trigonometrical functions. So only we can develop the function idea of the trigonometrical function idea only when theta is treated as function. That is not a ratio.
Yes, sir.
As any more question?
I think, sir, we are past the time.
Yes. You can conclude it.
Yes. So thank you so much, everyone. Thank you so much for joining today's session. As I mentioned in the beginning, our next session will be on 31st. Other details regarding the program and upcoming activities, we'll be sharing it in the group. Stay tuned. Thank you so much. Have a good night. Thank you so much, sir, for the wonderful session.
Welcome, welcome. Sir.
Thank you, sir, for the wonderful session. Thank you, sir.
I would request everyone, those who have not submitted the attendance, to submit the attendance. I have already shared the link in the chat box. If you have missed it, I am sharing it once again. If you have missed the attendance, kindly check the chat box. You will find the Google form for marking the attendance and complete the attendance.